Bismillahirrahmanirrahim. In the next coming lecture, I'm going to share with you a very efficient, interesting, and cool method of decomposing a composite number into its corresponding prime factors. Now, in order not to make the duration of that lecture too long, I am giving two preliminary short lectures as a kind of background because I'm presenting this lecture at the developmental mathematics. And I have already uploaded the first one, and this is going to be the second one. Okay, then let's get started, shall we? Now, I'm going to talk about divisibility in this lecture. Now, number one, I call it a skinny one, is my favorite number. It satisfies the definition of prime. Prime number is a natural number that is divisible by 1 and itself. But if we consider 1 as a prime, it will violate the premises of the hypothesis of the fundamental theorem of arithmetic. That indicates that every composite number can be decomposed uniquely into the factors of his prime, where up to the order of the product of the primes. And you know what that means because I've already mentioned that in the previous lecture. All right. Now, with respect to this theorem, 6 equals 2 times 3, and 6 also equals to 3 times 2, but it says up to the factor of the prime, product of the primes. So 2, 3 and 3 to 2 is immaterial, because the theorem does indicate that one. But if we consider 1 to be a prime number, then the uniqueness will be violated in the sense that one single example, in fact, is enough to contradict that, and that is 6 equals to 2 times 3, and also 6 equals to 2 times 3 times 1. And if 1 is a prime, then we are presenting 6 in two different ways as far as prime is concerned. Do you follow me? So that means 1 must not be considered as a prime number, because it violates the theorem. Now, the next prime number is 2. Now, in the set of what? In the set of natural number. And a number is divisible by 2 if the last digit from left to right, the unit digit of that number, natural number, is 2, 4, 6, or 8, even number. Now, 0 is considered as to be an even number, but 0 is not in the set of natural number. So we can say in the set of natural number including 0 or non-negative integers, every number in that set, in that natural number including 0, is divisible by 2 if the units if the unit number of that from left to right, the last one is 0, 2, 4, 6, or 8. Do you follow me? That is, any number with that description, in a sense, is divisible by 2. Now, what about 3? 3 is the next prime number. A number is divisible by 3 if the summation of the digits of that number is what? Is divisible by 3, which meaning when we add the digits of that number, it ends up to be a multiple of 3. I'm going to go over that when I zoom it and on the board. And then the next prime number is 5. And a number is divisible by 5, a non-negative integer, let's say, if the last digit, the unit digit, is what? Is 0 or 5. If the unit digit is neither 0 nor 5, that number, no matter how large or small it is, it will not be divisible by 5. You follow me so far? Now, the next prime number is 7. We have a way to find out if the number given to us is divisible by 7 or not, but the procedure is much longer than we go ahead and make long division. And if the remainder was 0, the number is divisible by 7. If the remainder is not 0, then the number is not divisible by 7. That's simple. Then the very same goes to 11, 13, 17, 19, and so on and so forth. So we have to know this list of primes when we try to decompose and composite number. Now let me zoom this one and stay out of way, and we go over this divisibility one more time with examples. Thank you. Okay. Now here is a big number, is that right? It's a big number. Now, this number, is it divisible by 3 or not? Try first to take all the product of 3 out, because the summation of the digits should be divisible by 3. So we don't need those that are products of 3. So 3 goes out and 6 goes out. Is that right? And 9 goes out, excuse me. Then those digits that we add, the summation of them ends up to be a 3. We also take them out for the same reason. So 1 and 2 is out. 4 and 5 is 9, and 9 is what? Divisible by 3, so 4 and 5 is out. Then 6 is already out. 7 and 8 is 15, and 15 what? Divisible by 3, 15 is out. So therefore this large number, 9-digit number, is what? Is divisible by 3. Do you follow me? Now, let's take the 9 out and see if it is still divisible by 3. Now, let me go one step down. Now, I took 9 out. Now, I have 8 digits, a large number of 8 digits. You can read it out. Let's see if this is divisible by 3 also. The very same thing, we go again. 3 and 6, they are what? Multiples of 3, they are out. 1 plus 2 is 3 is out, because we have summation of the digits should be divisible by 3. This is out. Then what else we are left? 4 and 5 is 9, and 9 is divisible by 3. This is out. 6 is already out. 7 and 8 is 15, and 15 divisible by 3. Therefore, this number, this large number, is divisible by 3. So don't let the last digit being even to fool your eyes, and you think, hey, this number may not be divisible by 3. You follow me? Now, let's take the 8 out and see what the number that is remain, if it is divisible by 3 or not. Now, I have to, let me go one step down. Now, again, the very same thing. Multiples of 3 we take out for the same reason. So 1 and 2 is 3 is divisible by 3, so this is odd. 4 and 5 is about 9, and 9 is divisible by 3, this is odd. 6 is already odd, so we are left with 7. But 7 is not divisible by 3. Therefore, this number, 7-digit number, is not divisible by 3. Do you follow me? Now we go to divisibility with 5. And I have written that one. So a number is divisible by 5 if the unit digit, the last digit from left to right, is either 0 or 5. And this number, the last digit is 0, therefore this number, this huge number, is divisible by what? By 5. And then let me go and have another example. This is again another huge number. The unit digit of this huge number is a 5. And therefore this huge number is divisible by 5. Okay, let me zoom this one back and say a few more words. Okay then, as I mentioned in the beginning of this short lecture, I'm intending to share with you a very interesting demonstration for decomposing a composite number in very efficient, simple, and cool manner. I haven't seen that one in any textbook, so it's going to be kind of new, and you can call it Alice technique. You can put my name on it. Okay, then I thank you as always. I thank you for watching, and again, as always, I wish you good health and prosperity, and I hope that this lecture that I'm uploading for the benefit of the public is beneficial to you. If you want me to give any lecture of a particular subject, a section, please indicate that in the comment section below, and I will be happy to make a lecture, a video lecture about that topic. All right, then again, thank you and have a pleasant day. So long.